Hello class. The purpose of this video is to go over StatTutor 5.1. Scripts should be posted on Canvas. So in the StatTutor you download the body image data and load it. It's called, well, let's go ahead and load it ourselves. For me it's in body image, my downloads folder. So I'm clicking on that. Keep in mind, we don't go to import data set, but we go to environment. Once you pop it in, it's going to be data. Notice it's 7 variables, not 4 like StatTutor 4.1. I can view it in a variety of ways. If I just click on data, then there it pops. Okay, so I'm going to close that. And I'm just working through my files. That was number 1. Second way, if I actually type in view data, then that'll do it too. So clicked on the run button and that ran this command. So that'll do it. If you really want to be direct, then you can use the bracket notation to call the first 10 rows of the frame, and then I'm not specifying which columns. So I'm just going to run that and show you. There they are. So, variety of ways to access data. All you really need is to get it up in the viewing window here and you're set. Okay, now getting into the StatTutor, there are definitely some things here that I want to comment on. So, first of all, it's asking us to plot the 2 variables. We're going to have high school GPA, explanatory, therefore x-axis. We're going to have college GPA, that's response, y-axis. So, I've set it up here, and I'm going to go ahead and run that, and you get this scatter plot. Now, that said, a number of you have been putting, let's see, I'm going to hit my up arrow and access the command. A number of you are putting in this, where there's just an X and a Y. That was generically stated by Acrobatic. Just that X is your explanatory, Y is your response. You have to type in the variable that you want. Oh, how do we know what we want? Well, we're going to pop over here and we're going to look at our data. So as you work through that thing, you had made a determination that you were looking for high school GPA and actual GPA. It's case sensitive, so this matters. If I type in, let's say, high school lowercase GPA, in fact I get lots of warnings. So let's make this one GPA, that's correct. And now it's got a different error here, but I'm going to put in actual GPA. By golly, that's the thing that I want. So that's my scatter plot, and we'll give it a little bit more view here. Okay, so there's my scatter plot. That's what we need to do. That's going to be all throughout this course. Now, I'll state it here, and everything I'm saying was already contained in the introduction to RStudio file that I had you guys work through. If you work through that thing again, you'll see all this stuff is already contained there. So let's try this plot, and let's see, where did I want to say? Oh, yes. Another way to do this that is kind of convenient, if I do what's called attached data, but let's not do it just yet. Let's do GPA. Error, can't find it. If I do data $GPA, then it gives me 232 values. That's too many to look at on a screen of this size, but there they are. Remember, GPA gave me an error. If I do attach data, then I can run GPA and I actually get the data. Now, if I go back up to that plot command, I don't need to call data anymore because data is on top of my table. All those values are accessible to me because they're attached. If I run this plot command here, it's going to work. you'll notice that it adjusted these labels. I'll show you later how to call the names of those. It's no problem. Okay, that being the case then, if we want to do correlation, then I can simply just rerun the same exact plot command that I ran before, but I want correlation. The syntax is you can think of it as the explanatory first and then the response. When you do correlation, it doesn't matter. You can flip them. Oh my goodness, it gave me an NA. That's because somebody didn't fill everything in. So what we do is there's an argument that says, hey, I want to use only the values where I have combined in Acrobatic. Oh, let's see. Well, in Acrobatic it says we can just use C. I forgot what the actual argument is myself, so I'm just going to type in the help for correlation. And I know you're not going to want to do this very much, so I'm not recommending it as a regular, but I'm just showing you how this can be done. And there's a little argument called use. And so when I look down here, it says use. It's an optional character string, and it's complete dot observations. Aha. So I hit my up arrow 2 times, and that got me back to this previous command. So if I type in complete, then it also gives it to me. Any abbreviation that's unique is going to work. Okay, so now I've got my correlation. Click back on plots. I've got my scatter plot. I am looking good now. Next up is regression. This is the spot that I think some of you may have become alarmed, and I really want to look at this. So here we go. This is Acrobatic's command right here. What's going on? Here's the syntax. The syntax is simply LM. It stands for linear model. And then there's a Y, that's the response, tilde, that's the X, that's the explanatory. This is the complete syntax of the guy. Okay? So in our case, our response is college GPA, and our explanatory is high school _ GPA. That is the whole thing. Boom. If I do it, there's my line. That's the linear regression line. What it's telling me is this is the slope and this is the intercept. So if you were to write it out, you would say y equals 0. Let's say 6192. I'm going to abbreviate, round that down to 0.62 x plus it's 1.07. That is my y-intercept form of the line that's going to be the best fitting line through those points. Okay, seriously, that's all there is to it. This is the full form. Now, the version that Acrobatic gives us, it looks a little bit clunkier, so let's work ourselves up to that. Okay, so first of all, notice I had this GPA, high school GPA. Well, using the Acrobatics way, we give the full thing, data, $GPA, data, $high school GPA. Oh, that's the exact same thing, same line. Now, they just put this L equals. What's L? L is whatever you want. So I'm just going to say U. Well, U equals linear model. And now if I type U, you might have noticed that it popped up here. If I type it, oh, that's the exact same output. I determined the name of the output there, so I've held it and I can call it anytime I want. Okay, now enter a new function. This is a bona fide new function in addition to that LM new function. And by the way, those will stay the same at the very end of the course when we do inferential statistics on this, so don't get alarmed. AB line. So AB line, if I do it on L, I didn't create L. Instead, we created U. So by golly, boom, it pops the line on there. All it's doing is drawing the the y-intercept, the slope-intercept form of the line on there. Okay, great. Now, I apologize to you that Acrobatic did this. It put a bunch of optional stuff to put a caption on. We don't need that, and I would recommend just ignoring that for now. You certainly don't need to do that for my purposes. One thing I would say is if you want to change the arguments, then let's see here. Whenever you do a graph, I'm doing my up arrow looking through for my plot command. Here's a plot. I'll just plot that one. XLAB is going to be the label of the x-axis. So in quotes, whatever you want to call it. Maybe I will just call this high school. And then we'll put it. Notice that we had a changed high school down here. You can imagine that the y-axis, I'm going to enter a new line just, oops. We'll, ylab equals, and we'll call this college. And you notice that it changed. If I do my back arrow, that's the previous graph. Back arrow again. Oh, that's the previous graph. And so on and so forth. Okay. You can work through the Acrobatic tool and think about the implications of this. That covered the first part, the regression. Part 2, the analysis of gender and how people feel about their weight. Okay, so they had a big old command that is kind of large. And so whenever you get a large command, that's intimidating. So break it down into its components. The first one is, you know the data. So there's 2 columns of data, but it's categorical data, isn't it? Oh, it's a whole bunch of male, females. So what's this thing doing? All this is doing is calling a data frame. It's making a data set with only those 2 variables in it. The table command is a beautiful command that just magically adds these guys up and puts them into a table. So I'm just going to call the table command and run it there. Boom. I've got a nice little table, female and male, by the 3 responses to how they feel about weight, about, over, and under. Awesome. So what Acrobatic did is they said, let's just call that TBL. Okay, great. We'll call it TBL. So I'll do the same just to keep consistent. TBL. Notice it popped up here. At this point, I can take that object, TBL, and whip it out whenever I want. Here's another packed Acrobatic command. I don't like that they do that. So we decompose it and row sums. You know what? That's a magic command that gives you the sums of the rows. So what they're going to do then is they're going to take the table itself. So I'm doing my up arrow, and I'm just going to go home and then do TBL in front of row sums right there, and then divide it. What did that do? Well, it made this sum be 100%, and it makes this sum be 100%. These are the conditional percents or conditional probabilities of the genders on how they feel. We want to do that because we want to compare apples and apples. Instead of just TBL, there's a different number of females versus males, so these numbers aren't directly comparable to each other in the categories. Awesome. So we can see that females, more females feel about right than males, and more feel overweight than males. It's just that more males feel underweight. Okay, if you take that whole clunker, and I'm going home, multiply it by 100, then we get in the percentage form we're used to seeing. Okay, so that's how to break that down and extract it. Let's go to the third one, which is the box plots. Acrobatic boiled it down into two commands, which frankly I'm not real enthusiastic about. I didn't show how to do that in my intro video. I just showed you the box plot command. Box plot command is great. It gives us what we want. The syntax for box plot is you put your y in front and then your x, just like the linear model. So if I do my up arrow here and go to that linear model syntax that I had, oh, this is a lot of up arrows. There it is, linear model. You can just go home on that and type box plot. And the problem is, my y now is a different variable. It has to be a numeric, but then I need a categorical over here in the x. Otherwise, that won't work. Let's try that. Yeah, that's not what we're going for. Okay, so let's just change that though, and let's put in the data for the seating arrangement. Seat. Now this is GPA by seating arrangement, and that in fact is what we did want. We're using the same response variable as the previous run. Okay, awesome. We've got back, front, and middle, and there they are. Okay, that's the box plot. It's not worried about acrobatic syntax there. It's a weird use of the plot command. Okay, now if you want to get the descriptive statistics for GPA, then as I taught you before, just use the mean command. And I'm running mean on data GPA. And, oh, running it on. Oh, it gives me NA. Ah, yes, we remember that what we have to do is we have to bring in that na.rm command. Remove those and make it true. The default is false. Aha, that got me the mean. Oh, the mean is of all the back, fronts, and middles together. That's not the most useful thing. Okay, here's a new thing. And this is what I got. So let me run that and tell you what it is. It's the exact same as the previous, but I only want the B seats. And so this argument right here is, there's no way to get around this. This is a logical. That's why it's got two equal signs. And what it's saying is when the seat is B, that's true. Those are the only ones I want. Look, I'm going to run it. Okay, let's do a copy and then paste it out. Okay, every single case. Let's look at the first few. False, 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 true. So the fifth one's true. Seats, false, 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 true. Yes, B first occurs in row 5. That's what this true is. Then I have false, false. Number 8 should be true. False, false, true. There it is, because the 9th one, here's the 9, is false, and so on it goes. Awesome. That gets me that. So if I run the mean only on those guys and remove the NAs, then that should do it. And sure enough, that's the mean that I want. Well, you can take that, do a little up arrow, and we're just going to change it to F. There we go. We're going to change it to middle. There we go. If you don't want mean, maybe you want standard deviation, maybe you want the whole summary, then voila, we get the whole summary and we're happy there. So you can access all those. That covers all of the R scripts for StatTutor 5.1. Little bit detailed there. You guys are starting to get into it. Let me give you a word of encouragement, okay? All that happens from here on out is we're going to add a new command, maybe two, but that's about it as we step into new statistical things. As far as the data analysis, this is the top. So I know it's challenging to work it this way, but this is really the top of where we go as far as difficulty. Once you're comfortable working with this, then you're there. You'll always have this to reference. You'll never be tested on your memorization of these because they're always available. Okay, God bless you. Bye-bye.